Welcome. So in this lesson, we're going to begin to talk about dilations, which is a different type of transformation. Now, dilations come in two different forms. They come in dilations from the x-axis and dilations from the y-axis. And it's really important that we know the difference between these two types of dilations. Let's begin by looking at dilations from the x-axis. And here's an example that looks at a dilation of just a single point. So it says a dilation of a factor of 4 from the x-axis. So we've got a dilation, it's a factor of 4 from the x-axis. We use the same notation as we do from our last lesson. So that last lesson about translation, we use this notation, we introduced it, and we're going to use it again. So we say we start with a point xy, and then x dash y dash represents our new point. Now, this right here, this 1, 1 represents xy. It's where we're starting from. Now, we're going to apply a dilation of a factor of 4 from the x-axis. If I'm dilating from the x-axis, what that means is that this point is going to be pushed away from the x-axis. So remember, this is my x-axis, and I'm pushing it away from the x-axis by a factor of 4. So it's going to end up here. And the new coordinate is going to be 1, 4. So hopefully you can see what I did here. I took my y value and I multiplied it by 4 to get 4 here. So this is the important thing that lots of people get confused about. When I'm dilating from the x-axis, I'm changing my y value. So as you can see here, x dash remains as x, but y dash is 4 times y. And then this is our final thing here, 1, 4 is our final answer. So make sure you understand that when you're dilating from the x-axis, you are actually changing your y value. We can look down here and see an example of when we're not just dilating a single point, but rather we're dilating an entire graph. So here we have a dilation of a factor of 2 from the x-axis, can be defined by the rule, this right here. And as you can see, we're starting with this graph here, and then after we apply our dilation from the x-axis, it's pushed it away from the x-axis to up here. So as you can see, they've got this arrow here, which is saying it's pushing it up, it's pushing it away from the x-axis. And as you can yet again see, my x value remains the same, but it's my y value that changes. So when you have a dilation from the x-axis, it is your y value that changes. That's important to note. Okay, let's keep on going. And now look at, let me grab my highlighter. Let's now look at the dilation from the y-axis. So here we have a dilation of a factor of 4 from the y-axis. So again, we start with our original point, and we're going to find what our new point is, x dash y dash. Let's look at the graph here, and you can see that our original point is 1, 1. And now I'm going to apply a dilation of a factor of 4 from the y-axis. Well, here's my y-axis. So that means I'm going to be pushing this point away from the y-axis. It's dilating from the y-axis, and it's going to take it over here. My new point is going to be 4, 1. So hopefully you can see what happened there. I took my x value and I multiplied it by 4. So yet again, this is where people get stuck. When I'm dilating from the y-axis, I'm multiplying my x value by the factor. So that means x dash is going to be equal to 4x, and y dash just remains as y. My final answer is 4, 1. Let's look here now. So this is now looking at dilating from the y-axis of an entire graph and not just one point. A dilation of a factor 2 from the y-axis can be defined as this. And as you can see, I'm starting with this graph here. And after I apply my dilation from the y-axis, it's pushing it this way. You can see the arrow there. It's pushing it away from the y-axis, as opposed to this one over here, which was pushing it away from the x-axis. And you can see that it is my x value that changes when I'm dilating from the y-axis. So this is one of those things that people get caught up on it. When I'm dilating from the x, I change my y. When I'm dilating from the y, I change my x. To really solidify that, let's go through this. So the type of transformation we're dealing with is a dilation. So if we're dealing with a dilation from the x-axis by a factor of a, so we're starting with our original point, our x dash. Now, if I'm If I'm dilating from the x-axis, my x remains the same, so x dash stays as x. If I'm dilating from the x-axis, it is my y value that changes, so y dash is going to become a times y, so ay. If I'm dilating from the y-axis by a factor of a, then it is my x dash that is going to be ax. So it is my x value that changes, and my y value stays the same, so y dash is going to stay y. Let's now do some examples in which we're just dealing with a single point. So it says find the image of the point 6, 5 after a dilation of a factor of 3 from the x-axis. So let's go through our notation slowly. We've got our original point. We're trying to find our new point, which we say is x dash y dash. X, y. So we're just rewriting it here. Okay, so if we're dilating by a factor of 3 from the x-axis, that means my y value is going to change. So x dash is just x. My y dash is going to become 3y. We now take our point 6, 5. That is my original point. My x stays the same, so just 6. And my y value is multiplied by 3. 3 times 5 is 15. That is going to be my answer. We then go to our second example here. A dilation by a factor of a half from the y-axis. So again, I'm going to say I'm starting here. I'm applying my transformation. I'm getting x dash, y dash. Now I'm going to have this. I'm going to have this. I'm going to have this. I'm rewriting it. Now, if I'm dilating by a factor of a half from the y-axis, it means my x value is going to change. So that means x dash is going to be a half x, and y dash is just going to be y. I now sub in my point, which is 6, 5. I'm going to go a half times my x value. 6 times a half is 3. And my y is just going to stay y, just 5. That is going to be my answer. Okay, I just want to pause here. And I'm going to stop this video here. In part 2, I'll go through applying dilations to entire graphs, but I just really want you to pause and make sure that you understand everything on this page here. This is the foundation of it. So with that being said, I will see you in part 2.